Traditional software application development usually involves database design and coding, user interface design and coding, back-end business logic coding, and product testing. Each step itself involves many tasks. The problem with this procedure is that everything is done from scratch virtually every time, which makes the business software application development costly and time-consuming. A new approach is developed to simplify and accelerate the process, so simple that no coding is involved, and so fast that it is almost instant. We call this new way as generalization. The basic idea is to design the database and the user interface as generic as possible. Both the user interface and the database are implemented in such a way so that it can be used in various situations. All data is designed as objects. There are two types of objects: entity object and relationship object. Entity object is defined by type. They are usually tangible things such as a company or a person. Entity objects could be at different states in its life cycle. For example, a company could exist in the following states: set up, in business, or out of business. These different states are defined by life cycles, which control different types of objects. Relationship object is defined by relationship. They are usually intangible concepts, such as employee. It is used to connect entity objects. The relationship either exists or not. The information that objects contain is defined by attributes, which are defined separately and added to type and relationship definitions as necessary. User access to entity objects at different states and to the relationship objects are limited by the access control in the definitions of type, relationship, and state of life cycles. When defining a type, we define the type's name, in this example, person. Then add attributes such as address, email to the type. We can also restrict the access to this type of objects to certain role such as administrator. When instantiating an entity object, we select a type and give it a name and an identification number. The identification number in itself or in combination with name makes an object unique. Then we add attribute values as necessary. When defining a relationship, we define the relationship's name, in this example, employee. Then add attributes such as salary, hire date to the relationship. We can also restrict the access to the relationship objects to certain roles such as administrator. We also define what type of entity objects could be on the has side, that is, owner's side, and what type of entity objects could be on the is side, that is, owned side. When instantiating a relationship object, we select a relationship and then select a has side object and is side object, add attribute values as necessary, and then connect them. When defining the life cycle, we define the life cycle's name and each state's name. In this example, the life cycle name is organization and the state's names are setup, in business, and out of business. Then we define what type of object it controls. In this case, it's type company. Then we restrict the access to each state of the life cycle to certain role such as administrator or manager. When instantiating an entity object such as a company XYZ, it is created at the setup state. An administrator user can move it to in-business state so that user manager can have access to it. With regard to the user interface, most of the times what users want to do is to create, modify, delete, and search their data. The user interface design uses menu just to do that. There are 8 main menus derived from 4 types of menus, that is, search, create, modify, and delete, for 2 types of objects, that is, entity object and relationship object. Additional submenus are added for more advanced object searches. Regular users have access to search, create, modify, and delete menus, but are limited to what they are allowed to do. The administrator has the access to extra user menus to attribute, type, relationship, and life cycle to define and maintain the database. Applications are developed in 2 steps, that is, design and build. The first step is to draw a data model diagram to represent the business process. The next step is to convert the design into database. This can be done either through the user interface or through spreadsheets. In this simple data model, we define 2 types of entity object, that is, person and company. Attributes are added to the types as needed. One relationship, employee, is defined with 2 attributes. One company can have many persons as employee, and one person can be an employee of only one company. For person A and company XYZ, we can state the relationship as person A is an employee of company XYZ, or company XYZ has an employee, person A. To use user interface to build the application, simply log in as an administrator and create the attributes, types, relationships, and life cycles as defined in the diagram. To use the spreadsheet to build the application, arrange the design definitions into one spreadsheet file containing 4 worksheets, namely attribute, type, relationship, and life cycle. Then import the spreadsheet definitions into the database using the Data Import menu. Obviously, this is a more concise, organized, and faster way, and therefore it is the preferred one. Either way, there is no coding involved. Please refer to the demonstration for more details. In addition, user definitions and access controls can be also defined in spreadsheet files and imported into database. The end product may be defined as an online generic database with user access control. It can be used in any situation where multiple users are working on the same set of data and they need to collaborate with each other. The benefits it provides are the following: simple and precise. Applications are designed as data model diagrams. Fast. No coding or testing is involved. Customized. 100% customized according to the user-specific diagram. Flexible. Information can be added or removed as necessary. Scalable. Application can be developed incrementally using spreadsheets. Easy maintenance. Data can be exported into spreadsheets and backed up easily. To further explore the possibility, please go to the demonstration menu for more details.